Great. Then I'll just say I'm Melanie McNeel, and I'm one of the faculty members in the chemical engineering program. I also am a graduate coordinator, so I work on the graduate program that we have in chemical and materials engineering. I've been faculty advisor for Society of Women Engineers previously for quite a while, been a little bit active with AKey on and off through the years. And my research has been in biotech and lately biofuels. So I'm going to hand this off to Gautam.
Yeah, hi. I'm Gautam Kumar. I am assistant professor in chemical engineering. I'm new to SDSU. I joined in fall 2021. Prior to that, I was assistant professor for 5 years at the University of Idaho in chemical engineering. I teach undergraduate senior lab, and my research is focused on mostly computational modeling and control in application to biomedical and neuroscience.
Okay, and then Anne, do you want to start off from the students? Okay.
Hi everyone, I'm Ann Clerkin. I'm a senior student here in the chemical engineering department. I came to San Jose State as a transfer student from a community college, Foothill College in the area here. I am currently, like I said, finishing out my bachelor in chemical engineering, as well as concurrently a master's in chemical engineering due to the accelerated program that we have here. I am involved in a couple of research projects here. And nice to meet you all. If you have any questions, feel free to ask.
Okay, Jackson.
My name is Jackson Failer, and I am also a senior here who's concurrently working on their master's in chemical engineering through the SAGE program. And I started off my studies at University of Nevada, Reno back in 2016. And after a couple of years transferred back to JC, decided I wanted to transfer out, come back in state, and went to San Joaquin Delta College for 2 years before transferring here to San Jose State, where I'm in my 3rd year. And it's been a great experience. And I think that's about it about me.
Okay, and Janan?
Yeah, hi everyone. My name is Janan Alzagari. Like Ann and Jackson, I'm also a senior chemie who's also working on my master's. And then in terms of my experience at SUSU, I came as a freshman, and so this is my 4th year so far. And then with respect to clubs and research, I'm a member of AKey, the American Institute of Chemical Engineers. So I attend some of their events. And then for research, I'm currently doing research with Dr. Rosenfeld, and it's a carbon capture project. And yeah, looking forward to meeting the rest of you as well.
Great, and Edgar?
Hello, everyone. My name is Edgar Ramirez, and I am also a 4th year undergraduate senior here at San Jose State. I did bounce around a couple of schools prior to coming, so I am a transfer student. I am involved in some research with Dr. Wagner that's a little more focused on carbon capture and sustainability with biomass. And yeah, looking forward to meeting some of the new transfer students or freshman students coming in, and yeah, excited.
Right, and I just want to thank everyone for taking time on their Saturdays. I know everyone's Saturdays could be filled with a lot of other things. And we thought we'd go through a short presentation just to talk a little bit about our program and some of the resources or opportunities we have for students. The students can jump into, our students here, the 4 that you just met, can be people that you ask questions of, or me and Gautam as we go along. You can feel free to type any questions you might have in the chat or raise your hand. And let's see, maybe Anne can keep an eye out too if you notice that there is a hand raised that we don't notice. I'm trying to keep an eye on
Yep.
all that too. Okay, but if that's okay with everyone, we'll just go through a short presentation, then we can open it up for general talking and discussion or questions. So, you know, one thing we always wonder, people the new students have to decide if they're going to join the program or maybe are wondering if they should even go into engineering. And it always seems probably once you're here, at least as faculty and seeing all the students that come through all the years. But if you like if you like your math classes or science, some type of science, it doesn't have to just be chemistry, it could be physics or biology. If you like one of those a lot and you can get along with math, even if it might not be your favorite or it is your favorite, maybe you like to look at the economics of processes, or you care about society and you want to do something to make a difference. Engineers are trying to solve problems using, in our case of chemical engineering, math and science, along with economics, because we have to make a profit to keep the company going. But we try to solve real life problems that make a difference for people in the area of disease, pollution control, finding new energy or fuel sources, maybe addressing challenges like providing the worldwide drinkable water for everyone, which isn't currently available, fighting terrorism, or to keep up with the demand for faster, better computers or better smartphones. So chemical and materials engineers, many of these areas I've just alluded to right there, have a multidisciplinary aspect. So it's not just chemical engineers you'll work with. And then even if I ask those 4 seniors that you just talked to right now, like, what is a chemical engineer? They might not be able to answer. So sometimes people, even by the end of the degree, they might not always be able to answer because chemical engineering is so broad. And, sometimes you will have something like your parents think that you're doing something like solving equations and all that. Sometimes your faculty think you're not studying and getting your work turned on time. You're out at the local restaurants partying. Or maybe what you actually do, as the seniors know right now, they're all working on their capstone design and they're writing out the flow diagrams for processes that they're designing and developing. So there's a lot of different things that you can do as a chemical engineer, and people might not ever know exactly what you do. So chemical engineer, we take basic sciences, physics, biology, chemistry, apply them to the conversion of raw materials into viable products. So you merge together some idea, usually that the chemist or scientist had in the lab, we make it work in industry. So we scale it up from the lab scale to full production size so that we can provide it to everyone who wants to buy it, and we have to do that safely and in a way that makes a profit. All kinds of things are chemical engineers that you may or might not have thought about. Petroleum engineering is the old type. I mean, originally that was a big area of chemical engineering, but all the supplies you use in your house come from usually a chemical engineer at Procter & Gamble or all of those Kimberly Clark and all those other companies. They are providing that material on a large scale. Not only chemicals like that, cleaning solutions and all that, but all food items have a lot of chemical engineers working for them. Semiconductors, we have a lot of semiconductor companies around here, Applied, Lam Research, Philips, they hire our students. Pharmaceutical production and manufacture or drug delivery, like patches. These other 2 drawings aren't as self-explanatory that just came up, but those are all ways of building together synergistic processes. The one on the right with the floating orange things are to gather energy from the waves. And the one on the left was something that we worked on with a researcher from NASA who was trying to use algae and solar cells to provide energy and clean water for third world countries. So there, you can put together very complex things when you're working on chemical engineering. You do get paid a fair amount for what you do. So chemical engineering tend to be, we're the third line up here. If you just go down all of the other degrees, we tend to be on the high end of the scale for starting salaries. This is a national average. You might know in the Silicon Valley, we do tend to get paid higher because there's a lot more technology companies here and they're competing to hire engineers. There's not enough engineers, so your salary goes up. I think some of the students were talking before we got started that they could probably pretty easily see salaries of 80 to 90,000 for their first job. And at SDSU, we have our program, our curriculum is a math-based curriculum, but the support, so that could scare people a little bit, but that you have a support system that makes the curriculum easier. You have 4 students here that have made it through, so they could concur or not, but your course professors can help you. There's a very strong academic counselor network. Here's the Student Success Center in the College of Engineering, along with your own academic counselor in the department. There's student clubs, your student peers in your classrooms and friends. And a lot of you will probably have support encouragement by your parents. You also get, besides the curriculum, you get to get some hands-on application that usually helps people understand better what they're doing through industrial internships, because Silicon Valley is right around here. Undergraduate research opportunities. I think all these students are working on their undergraduate research. And our curriculum overview is broken down, as you can see, where you have general ed, math and science, a common area of engineering that's outside of chemical, your chemistry and other science foundation, and your major classes along with your technical electives that will give you depth in an area. The total is 120 units, and our tracks for your electives are usually broken out down to these. You can have a different one, but our main ones are biochemical engineering, semiconductor processing, environmental health and safety, polymer ceramics processing, and energy, which is usually alternative energy. So those are where you would usually pick your courses in one of those tracks, your elective courses. And we also in the department do have some scholarship opportunities. We have the Jonk Award, which is $15,100 a year, usually awarded to a junior. And then we have some new freshman and transfer student awards that are going to be awarded to at least 2 students who are enrolled in chemical engineering in fall 2022. So for the new class. And we usually have students awards that are about $200 a year for things like outstanding senior, outstanding junior, promise award for our sophomores and juniors. I have a McNeel reactor design award because I used to teach that class all the time. So, and then we have a most likely to succeed in chemical engineering award. So sometimes GPA alone doesn't determine that someone is going to be good. There's a lot of really practical students who don't do well under the pressure of exams. So a lot of times we're acknowledging students that we think are going to succeed in chemical engineering, even if they might not be the highest GPA. And then we have various types of experiments that you work on or try to understand. Condensers, which are, you might be removing heat or adding heat to a system. You have fluidized bed, packed beds, heat exchangers, reactors, kinetics experiments, all types of things that you can work on in the lab. These are our former students. Every year we have a senior project. If anyone here wanted to ask any questions, but the 4 seniors that are here right now in this room, they are working on their project, but we go out to local industry. Some of the ones that you can see here, Genentech for biotech, NASA, Ames is right up the street, PG&E, Mango Materials, and the like. And those here's some, I think in the next slides, it will talk a little bit more about what the mission might be of those particular projects. The industry gives the faculty member who's running that, Dr. David Wagner runs that capstone course. They give him an objective that he relays to the students, and the students have to solve the problem that they're given. For instance, here's the problems that they were given to develop a solution for. And I think the next slide might also have a few other ones. So DuPont came in and wanted some ideas on how to make a certain amount of propane diol, PG&E wanted to have a thermochemical conversion of forestry biomass into biomethane because they can use that in their plants. Biofuels are big now. So EPRI has a coal-fired retrofitting for their biomass energy production process. So they came up with an objective for the students. And so the students work on that and develop a full pilot plant that can carry out the objectives. They analyze the safety, environmental impact, the economic profit loss, financials, and then they present that to the faculty and the junior class and the industry sponsors and our industry evaluators every May. Our upcoming one is on May 13th this year. So in about a month. I hope you guys are ready. So you don't have very much longer. We also have good internship opportunities at SDSU. So our students have been at internships with the area companies. A lot of times those will be advertised on the company's individual web pages, but we have contacts at those companies. And when they send us a request, we send it out to the student groups by email so that they could apply if they're interested. I think Gautam, am I right, Gautam? Are you?
Yeah,
Yes, you're starting. Okay.
I'm going to. So we a year ago we started the SAGE program where undergraduates can spend one more year and get their master's degree also with their bachelor's degree. And we have a couple of students here who are in that program, and this is a first batch. And the application usually start during the junior year, and you start working towards your master's in your senior year, where you take the courses and start your research. Throughout your undergraduate study at SJSU in chemical engineering, you will find plenty of opportunity to get involved in undergraduate research with our excellent faculty. So our faculty are not only excellent in teaching, they're also internationally renowned in research in the field which I call modern chemical engineering. So we typically encourage in our curriculum, we typically encourage our students to get involved as early as possible so that you will have plenty of time to explore different kind of research with different faculty. You don't have to stick with one faculty. You can switch among faculty and learn more about research, what kind of research they are doing. So for example, Dr. Leather Rosenfeld, she applies chemical engineering principles, particularly the microfluidics, to develop novel type of technologies for rapid detection of pathogens. She also works on carbon capture, which one of the students here, Jinan, is working on. Then we have another faculty, Dr. Anand Rama. He uses chemical engineering techniques such as chemical kinetics to understand the mechanics of blood cells so that he can facilitate development of novel technologies, novel types of treatments for blood-related diseases. We have Dr. Ketty Cow, who is expert in biomedical engineering, and she uses in her research genomic tools and systems biology to develop technologies for bio-based productions of fuels and chemicals, which are typically used in nowadays going to be used in space, particularly in Mars mission. Then we have Dr. David Wagner, who is expert in sustainability and green energy. His works, he has several works and experimental focus on thermal analysis, fluidization and process intensification, sustainable and green technology for energy and clean water. He also does computer simulations. He teaches a design course here, senior design course, and he also is involved in educational research such as K-12 and higher education. Then we have Dr. Melanie McNeel, who is also here. She's expert in catalysis, kinetics, membrane, and she has worked on biodiesel. And we are currently using her expertise in generating biodiesels in our senior labs. And then we have faculty, Dr. Clerk comments. She works in developing with developing countries where she's developing low-cost snake antivenom. And then I work on my research is basically on modeling control applied to neurochemical engineering, which is more related to brain. And I use this modeling and control techniques to develop novel type of brain stimulation techniques or strategies for various brain disorders such as Parkinson's and epilepsy. So most of our faculty are funded by National Science Foundation, National Institute of Health, NASA, and our faculty are also involved with have industrial collaboration. So that provides a lot of opportunities for undergraduates to get involved with industry early on too. And then we have several professional society student chapters in which you can get involved, such as American Institute of Chemical Engineers, International Society of Pharmaceutical Engineers, Society for Women Engineers, Black Alliance of Scientists and Engineers, and Society of Latino Engineers and Scientists. If any of you can talk a little bit about your experience with the club or anything you have done, that will be appreciated here.
Janan, did you have, okay.
Sorry, I was just going to touch on, I've done a little bit with the American Institute of Chemical Engineers, more so I would say in my freshman and sophomore years. But I think in terms of the organization as a whole, what I liked about it most is just that, like with respect to something like a career fair or something, for the College of Engineering, a lot of times it was, more skewed towards like software or computer engineering positions. And so like AKey recognized that and held their own Chemie career fair my freshman year. And so that was really cool just to see, like, it was a smaller career fair. There were companies that were a little bit more relevant to the major. So things like that, I think they're really good with networking overall.
Yeah.
Thanks, Jan.
I can add a little bit on the AKey Club as well. I am not an officer, I'm just a member, but just from what I've seen, what the AKey Club offers. So there's study groups, there's help. We're actually right now trying to organize for study group for the FE exam, which Chemie graduates could use. And then just connecting us to, like Janan was saying, particularly opportunities geared towards Chemie instead of being a little more generic with compared to the career fairs.
Yep.
Thanks,
Great. Thank you.
So I hope like this might have generated some questions in your mind, and we will be happy to answer any question you have.
I do have a question. I'm admitted as a transfer student for materials engineering, and I was curious how difficult the process is to switch to chemical engineering after the first semester or 2 semesters.
It's pretty straightforward. In fact, they have, I could get you a link. All of our emails are on the website. I think it'll be, if you forget, but I'm just melanie.mcneel. I think my name's up there, at sgsu.edu. There's a simple form. And because materials engineers and chemical engineers, I think they take exactly the same classes the first semester for sure. And I think even the second. It's a really straightforward process and you don't lose any time.
Thank you very much. So it's definitely possible.
Yes. There is something on the website too, not the SGSU website, because they have a form that's different if you have 60 or less units versus if you have 60 or more units and you want to change majors. But it's a lot of people change majors. That's part of your job of going to college, is figuring out what you want to do for the rest of your life, or at least some part of your life, right?
Dr. McNeel, can I just add something
Sure.
to that? I know that here, our chemical and materials engineering, I guess, department are interdisciplinary. So you can, personally, for my case, I am getting a master's in chemical engineering, meaning I'll be taking classes geared towards a chemical engineering degree. But my research is with a materials engineering professor. And I'm working on materials engineering work for like battery research. And so you could go either way if you're not entirely sure or if you want to get the chemical engineering degree, but want to work on materials engineering research, you can do that, from my understanding.
Yes, definitely. And we're in the same program. I mean, we're in the same department. So chemical and material engineering is in the same department. I know from the graduate level, same thing. What was just said by Anne was that we have students who got their chemistry degree and they end up get an MS in materials, or they got a materials degree and they end up getting a MS in chemical engineering. It just depends on and your research and your electives really can give you depth. So you could be a chemie who goes on the materials track and you get depth in materials, or vice versa in materials. So there's a lot of options, and we really encourage you to think about what might best suit you.
Yeah, I would add that I don't know any other discipline which is as broad as chemical engineering. And being a chemical engineer allow you to move in any direction in life, wherever you like to. I started working as a chemical engineer, but now I am doing more of the brain stuff.
Right.
So it's completely different than what I was trained for initially. But after thinking over years, I thought that if I wouldn't be a chemical engineer, probably it would be much difficult for me to switch to this new area, because chemical engineering prepares you for all these things.
Right. You take so much science really and the math background. And then your fundamental engineering courses are based on the equations that allow you to apply that. Really, they're the same equations, but they're applied to all these different fields like environmental or nanotech, biotech, food, cosmetics. I mean, it's amazing. You just have to learn some of the buzzwords, but you have the fundamentals. And I feel like chemical engineers are a little bit more able to switch when the market goes up and down. Like I watch some of the people, I'm not going to say what major, because a lot of these topics are interdisciplinary, but I'll just say when the semiconductor industry, if you watch it, it goes up and down, wild swings. And sometimes if you only have a certain degree, you're not able to pivot to another technology as easily. You still have, people will try to pigeonhole you a little bit. When you're a chemical engineer, you can bring up other topics and labs and research you worked in to pivot to a new technology area.
I think there's a question, is biomedical
Yeah, there's a question I was going to say.
in the same department as well?
Okay, so it used to be, but I think they wanted to go, they were getting big enough that we decided to split into several departments. Like one of their faculty, Falaran Aragbabo, I just mangled his name, but he's a chemie as a degree, and then he ended up getting a PhD in biomed. So he teaches over there. I always tease him about coming back into his real major of chemical engineering. But that's another multidisciplinary field. So what is interesting about biomedical is it's an umbrella that holds a lot of specialties. And you have to look at every university and see what they happen to specialize in. This university kind of specializes a little bit in devices and prosthetics and some imaging or things like that. So they could do this too, but they don't happen to. But chemical engineers pick up the biomedical, that is drug delivery, maybe making patches, for instance, to pass drugs or little liposome covered drugs that pass through your stomach. So it gets to where you want. Also drug discovery. So running a bunch of tests to see what drugs might be most effective against some disease marker, and manufacture. So we're more on that side. We do some imaging, and there's overlap with materials, the biomaterial side of it. Both Kimmy and Maddie go into like making stents or things that might be used in the biomed area. We kind of have that slice of the pie here at this university. So we are separate departments, but we do overlap in a number of topics.
There's another question from Joshua. Is the program impacted?
We're not impacted. We're one of the smaller engineering, both chemical and materials engineering is on the smaller side compared to the big ones, which tend to be really electrical and computer. COVID hit everybody a little bit, but they're building back up. And then mechanical and civil used to fight it out for who else was the second tier. Those tend to be the really big, where they might have 100 or more students in their classes. we tend to be more on the 20 students, 20 to 30, maybe 40. A few years ago, we were up to 100 too. So we swing in there a little bit depending on what's going on in the economy, but we're not impacted.
Yeah, but that's the good thing that we have a smaller class because and the faculty to student ratio goes up, right?
That's right. Yeah. So you can get more input for yourself personally. I know for myself when I'm teaching more than, it's somewhere between 30 and 40 students. I cannot remember everyone's name all the time, so usually if I'm in the 20 or 25 or below, by the first time I'm handing back homework, I can associate names and faces. But once it gets above a certain level, there's a certain number of people that I think the faculty never know, especially those ones that are 100 or above. So I think there's a benefit because when you leave, a lot of times you need letters of recommendation to get a job, to go on for your graduate degree. And in chemical engineering, I think the students could address this, but especially you're working on research, I know some of you too have gone through Dr. Wagner to ask him to, contact me for something. You have your faculty, how can I get this thing that I want? Okay, here, I'll put in a good word for you and you'll get what you want. So I think that when you know your faculty, it's a big deal for future things. Sometimes by them knowing you, if they have friends in industry, we all have a lot of contacts in local industry. Someone will come and say, hey, I need someone to start this internship or a full-time job. Do you know anyone? Well, if I know you, I'm more likely to say, yes, I know the student, contact you, get your resume over there. They're looking for someone right now. So I think there's a lot of advantages. And I think even if you go in a big program, you should really make the effort to make sure those faculty know who you are.
So we do have, I think, replied about the current batch of seniors, but how many students are in the undergraduate chemical engineering program currently?
Okay, so it seems like, I wish Dr. Rosenfeld was here because she had been doing the undergrad advising, but I think that in undergrad, okay, so are we talking about freshman, sophomore, all of them? All that?
I think so.
It seems like we're up to 250, about 250 total.
Yeah, then Nicholas has a question. No issue with being waitlisted for classes then, of course.
No, not well. Okay, so your first couple years, you're taking all those big math and chemistry, physics, and things like that. So you definitely want to jump and get when your enrollment time is here, if you can, jump right in and get that, because those classes are, if you're a transfer student, usually no problem, right? Because you're taking all major classes. But before that, can you guys mention it, the students, did you have any trouble with getting in chemistry or any of the, like some of the labs, I think were hard to get into?
Yeah, I'm saying that there's still competition for chemistry.
Okay, that's, yeah. But not in chemical engineering, the actual classes.
Classes and says like a not called classes, not elective.
And in general, if I may add, and one of the benefits to this being a pretty small group is a lot of us are able to get to know each other, and you really get to know everybody in your class. And if you, I'm sure if you really have any scheduling issue or you commute and the day won't work or something, you just have that one lab session that doesn't work, you can talk to people, and I'm sure there will be somebody who's willing to work with you and swap with you. And it's really seems to be a really friendly group, and you really get to know everybody. So that is something to consider as well.
And I'm just going to jump on that too, because I do think when the students go out and they graduate, when they get into industry, because usually you'll know the juniors. Is that still true? I know COVID kind of curtailed some of it, but do you know some of the juniors from walking around the building right now or not? Do you guys feel like
I personally only know the senior class. I've met a few junior people because we work in the same lab with Dr. Rosenfeld, but I don't know the larger body of the junior class.
And how about the prior seniors before you, when you were juniors?
Only the ones who are currently master's students.
Okay, right, which is another, the only reason I bring it up, it's amazing how many times you get out in industry and because you know these people in your class, or sometimes whoever you meet by the other means, when they're out there and they have an opening, they are going to contact you and see if you're interested. So the networking aspect is helpful, and it goes on. It's like it ripples out when you graduate. Let's see if
I'm not-
anything else we can answer for anyone. We are going to send out a follow-up email for everyone, and we might set up an additional time for question and answers. Everyone, I hope, knows that by May 1st, if you're coming to San Jose State, you have to submit your intent to enroll and I think pay a fee. And then you'll know what major you're in or what you've chosen by that date for sure. But I just want to make sure if you want to go to the university and start next year, make sure you don't miss that deadline. They're really strict about it. And you're free to contact either me or any of the faculty really, but me or Gautam. You can email us, and we have our admin, Debbie Fennern, which you'll see listed on the website too. She can track us down. You can leave a message at our main phone number, which is 408-924-4000. And if you wanted to have one of us give you a call back or send you an email answering a question, we can get that done too. Okay, all right, good. So you have a couple
Email
emails
address-
in there?
Yeah, email address is quite simple. Like you just look at the first name and last name and put a
Yeah.
dot in that and @sjsu.edu.
Yep. And was there any topics of particular interest to anyone that you want to find out more about, especially from the students who have a closer experience to what you will be experiencing? Okay, I personally don't see anything. I don't think
If
that.
it, I was gonna say, if it helps to spur anything, I forgot to mention earlier, and I think I'm the only one here who my research is having to do with bioenergy and renewable energy. So if there's also anybody who's curious about that, it's also very interesting.
Right. Are you doing carbon capture too?
Yes, I'm doing bioenergy with carbon capture.
Okay. Yeah.
So it's a bit of a hybrid thing.
Yep. Now, I think if we don't have any other questions, we didn't want to keep you, but we do have our own website, and we do, I think this video is going to go up. So I hope everyone had to sign that thing that you know that they were videotaping this. And that will go up so you can reference anything that you might not have remembered when this was happening in real time. Again, you'll be able to be free to contact us after watching that video too, or any other time between now and when you start the program. And good luck in your decision making. Anything else that anyone wants to say?
Yeah, I think I just put the link for our departmental web page too.
Oh, perfect. Okay.
So anyone interested in looking more can look into that too.
Yep. And thank you everyone again for coming, and the seniors for taking some time out of their day too.
Yeah, thanks much, everyone.
All right. Bye.
Bye bye.
Bye.